If I were to suggest that the sun's cycles might have an impact on your entire life, you might assume that I'm departing from my usual focus on astronomy and venturing into the realm of astrology. While astrology posits that the positions of stars and planets can reveal insights about the future, that's not the perspective I usually embrace on this channel. My primary interest lies in the wonders of space and the scientific explanations behind its phenomena. However, occasionally, even the most surprising stories contain a kernel of truth. So, allow me to put on my fortune-telling hat. While I'm no astrologer, I'd like to predict that, based on the current state of the sun, you might encounter challenges related to your health, experience tech disruptions, witness warmer weather with clearer skies, and perhaps even notice unexpected influences in the coming years. How do I know this? Well, it turns out that the sun, that massive fiery sphere in our sky, isn't just our energy source. Scientific research is beginning to suggest that its 11-year cycles could be like the metronome that measures the beat of life on our planet. Tick, tock, ticks. Today, we'll delve into the subject of solar cycles, and more specifically, I'll demonstrate how the sun's cycles are already shaping your daily existence. The sun has an undeniable influence on life on Earth. In many ways, it's the origin of life itself. Life on Earth relies on energy to function, and the sun consistently provides that vital energy. Sunlight nourishes plants, plants sustain herbivores, herbivores feed carnivores, and so on, creating a complex food chain. It's challenging to find anything on Earth that could exist without the life-sustaining power of our sun. Yet, aside from being a source of life-sustaining energy, it's easy to perceive the sun as unchanging. We see it rise and set in the sky, but we seldom notice any notable alterations. However, this is a deceptive notion. The sun is in a constant state of flux. As science has progressed, allowing us to shield ourselves from the sun's intense glare, it's become possible to study the sun's surface. As early as 1610, it was apparent that the sun is a seething, ever-shifting sea of barely contained plasma, which occasionally isn't contained at all. Despite the immense gravitational force holding it together, the nuclear reactions at its core are so scorching, reaching temperatures of 15 million degrees Celsius at its center, that plasma bubbles and erupts on its surface, manifesting as solar flares that radiate in all directions. Sunspots, which are dark regions on the sun's surface with intense magnetic fields and can span from 1,600 to 160,000 kilometers across, form, migrate, and vanish. Coronal mass ejections, CMEs, erupt from the sun's corona, the atmospheric layer above the sun that's inexplicably 200 times hotter than its surface. There are few places in the solar system as dynamically active as the sun. What many people may not realize is that this activity fluctuates. The sun operates on an 11-year cycle, oscillating between periods of low activity, the solar minimum, and significantly heightened activity, the solar maximum, before returning to a lower state once again. During the solar maximum, sunspots, solar flares, and CMEs become more frequent. During this period, you are 50 times more likely to witness a solar flare than during the solar minimum, and significant CMEs change from occurring sporadically to multiple times within a single day. This cycle is known as the Schwabe cycle. Interestingly, this cycle is just half of a larger pattern called the Hale cycle, which tracks changes in the sun's magnetic polarity. Every Schwabe cycle, or every 11 years, the sun's magnetic north and south poles swap places. When another Schwabe cycle commences, the poles switch back, tick, tick, tick. This consistent ebb and flow of solar energy levels pulses through our solar system, rising and falling like a heartbeat. Surprisingly, even though we can't see it, we on Earth are synchronized to its rhythm. The cause of this sun cycle remains something of a mystery. It is clearly tied to the sun's internal magnetic processes. However, despite 2 centuries of observing these cycles and recognizing their impact on Earth over the past 10,000 years, we still lack a definitive explanation for why the sun's cycle has precisely this duration rather than any other. What drives this rhythmic cycle remains a question without a clear answer. The cycle of the sun, about 11 years in length, shares a resemblance with Jupiter's cycle, but this may just be a coincidence. While Jupiter is substantial, comprising 2.5 times the mass of all other planets combined, and does exert some gravitational pull on the sun, it cannot account for the seemingly random variations in the sun's cycle. Much of what happens within the sun remains a mystery to us. However, its influence on Earth is much more observable. Moving on to the space around us, its significance in modern civilization cannot be overstated. Therefore, it's not surprising that coronal mass ejections, CMEs, and solar storms emanating from the sun can impact our space-based technology. Scientists can predict the arrival of a geomagnetic storm at Earth days or even weeks in advance. This foresight allows astronauts to seek shelter to shield themselves from increased radiation levels and enables the safe shutdown of delicate satellite hardware, preventing potential damage. This is crucial as solar radiation can lead to unexpected electrical surges, overloading systems not in a safe standby mode. However, there's an unexpected consequence of geomagnetic storms. The radiation affects the atmosphere itself, warming it ever so slightly. As the atmosphere warms, it expands, influencing our satellites. In space, where there's no atmospheric drag, objects can orbit almost indefinitely. Although, in low Earth orbit, satellites need to adjust their orbits about 4 times a year due to the presence of a small amount of atmosphere. During a geomagnetic storm, the atmosphere expands, requiring LEO satellites to maneuver every 2-3 weeks to counteract the sudden increase in friction. Sometimes this isn't sufficient. In 1989, an exceptionally powerful geomagnetic storm caused the NASA Solar Maximum mission to plummet as the heightened atmosphere abruptly slowed the satellite. Ironically, the mission had been studying solar flares. This incident is not isolated. After each geomagnetic storm, NORAD relocates hundreds of satellites that have been displaced from their previous orbits. Radiation also impacts our ionosphere, filling it with charged plasma. This can slightly alter the path of GPS signals, reducing their accuracy from within a meter to over 10 meters. So, the next time your GPS suggests you're a street away from your actual location, a geomagnetic storm might be the culprit. Our power grids brace themselves every 11 years for the increase in these current-inducing events to prevent overload. Amateur radio enthusiasts and airline pilots experience significant drops in high-frequency radio range as radio waves are deflected or even completely obstructed by the more heavily charged ionosphere. As I foresaw in my horoscope, this all contributes to less reliable technology. The upcoming solar maximum, anticipated in 2025, strengthens my confidence in this prediction. However, there are positive aspects to consider. As space weather becomes more turbulent, regions like Canada witness a surge in the mesmerizing display of auroras across the sky. Aurora chasers report more frequent sightings, ranging from a few times a year to as many as twice a month during the most active phases of the sun's 11-year cycle. The sun's influence. Let's explore how the sun's activity affects space and our technology. You might assume that's where its impact ends. After all, can it really affect living beings? Surprisingly, yes. It's not for nothing that my horoscope mentioned potential health concerns. There's a growing body of evidence suggesting that the sun's cycles can influence ecosystems and species, including us. Some of this influence is indirect. When the Schwabe cycle is at a solar minimum, the sun emits fewer solar winds, which means we receive less protection from our heliosphere against cosmic radiation. This type of radiation is highly energetic, but fortunately, it's usually absorbed or deflected by air molecules in our atmosphere. However, even reaching the atmosphere can have an effect. There's a theory, though not yet confirmed, that this additional radiation could be generating nucleation sites in the atmosphere, leading to the formation of extra clouds and potentially influencing our weather. Even if this isn't happening, during a solar maximum, the space weather impacting our atmosphere can cause a slight rise in global temperatures. This aligns with the warming mentioned in my initial horoscope. It's not a drastic change, just under half a degree, and the temperature eventually returns to its starting point. Yet it's enough to be noticeable to species attuned to temperature changes, like when to initiate mating seasons. Studies on birds have revealed that in warmer years, they tend to lay eggs earlier. Interestingly, a study from 2009 by researchers in the Netherlands suggested that the laying times of blue tits were also influenced by the number of sunspots, a phenomenon that puzzled even the researchers. Birds don't have the ability to observe sunspots, so the connection remains a bit of a mystery. This isn't restricted to specific bird species or those sensitive to magnetic shifts, like homing pigeons, which adjust their flight routes depending on the phase of the 11-year cycle. Now let's address the last point in my horoscope: potential health concerns. There are numerous studies examining how solar cycles might impact us. For instance, in 2011, a study spanning 2 decades and involving nearly 1/3 of the women in Holland found a spike in 6 cervical pathologies shortly after a solar maximum, when the sun's radiation is most intense. The study also observed 1 man during the same period, though it was a smaller sample size. Nonetheless, it was intriguing to note that he experienced slight increases in oral temperature, pulse rate, blood pressure, and respiration rate shortly after the solar maximum. The influence isn't solely physical. There's even a connection to the incidence of mental disorders. A 2006 study looked at 237,000 clients in the main Medicaid database from 1995 to 2004. They discovered that clients born during higher energy chaotic cycles had a higher rate of mental disorders. The sun's cycle at the time of your birth might have had a subtle yet significant influence on the course of your life. It's not quite like traditional star signs, but astrology might be onto something, at least when it comes to this particular star. Health impact. It's important to note that ongoing research is still exploring this topic. Any health effects stemming from these cycles are incredibly minor. As one researcher aptly put it, it took a vast number of patients to even detect these subtle impacts. The sun's cycle should by no means deter you from living your life. We're currently approaching a solar maximum, projected to arrive. In the year 2025, there's no need to worry about living through or being born during a solar maximum. Surprisingly, this natural phenomenon isn't all negative. According to the same research, it could potentially boost creativity and adaptability in individuals. It's fascinating to consider that around 80,000 years ago, during one such solar cycle, a mutation in the human brain may have occurred, granting us the remarkable abilities of abstract thinking and consciousness. If this is the case, we owe a great deal to solar maximums, as they might have given us the ability to perceive the universe as we do today. Without them, we wouldn't be who we are. While the sun may have played a crucial role in shaping our minds, gaining knowledge and skills to fill our intellect isn't as simple as receiving divine knowledge from above. Learning is a lifelong journey,